them than we've been doing. This has well, first thing, I always start looking at the denominator. I know what to do here. What do we do here, class? 2 and all lower powers, right? Is that right? But here is one you haven't seen before. So here's what I'm going to do, and then I'll explain. We'll do it like we've been doing. We'll write the whole thing off to the side. What do you think about that? That's a little bit different than what we've been doing. Let's set this thing, I'm sorry. None of us need a concert at 8 o'clock in the morning. Here's the rule. First thing, this one resulted in these two. That's old news, right? We did that on Monday. Then this one is an irreducible polynomial of power higher than 1. So here's my new rule. Would you say that that x squared plus 1 cannot be factored? Yeah, I can. Yes. Yes. That cannot be factored and is of degree 2 or higher. Then in this rule 3, all that says is this: if I've got something with a degree higher than 1, and it can be factored. Then I represent every power of x in the numerator that is less than that degree. So this is 2, right? Here is x to the 1. Does everybody see that 1? And here is x to the 0, is it not? Follow what I'm saying? That's all you have to do. From there on, it works the same way. If this had been 3, you would have had 2, 1, and 0, wouldn't it? Okay? All right? But we're going to do it the same way. So, I'm going to multiply by the denominator, and that will clear all of the fractions. So on one side I have, notice all I did is call this I. I'm not going to do anything else to it for a while. Then I have minus 2x plus 4. And I have, I don't know if I'm going to have enough room there even, times is equal to ax plus b times what? X minus 1 squared plus b times x squared plus 1 plus c times x squared plus 1 times x minus 1. Let's see if we did that right. I am multiplying everything by this. So if I multiply, and I left off a square right there, didn't I, when I copied it. So when I multiply this times this fraction, all that's left is ax plus b times x minus 1 squared. Follow? Then I go over here and I do the same thing. That leaves b times x squared plus 1. Then I go over here and do the same thing, and that leaves x squared plus 1. But one of these and this divide out, so I still have one of those. Follow what I did? You're just sunk if you don't follow that, so stop me now. Stop me now. Everybody okay with that? William?
Yeah.
Write it out if you have any trouble at all. All you have to do is write this out. Write this out next to each of these, and then start doing that word. Okay? Which one of them's bothering you of the...
Just wondering why x plus b gets that, and then the rest will just get, I guess, because is that because that's within a square, is why it's just b and not like...
Yeah, isn't that this rule? This one has a square in it. So that means I have to have x to the first power and x to the 0 power. Isn't that what this rule says? And that's why it gets a x to the first plus b x to the 0.
Okay.
We need some help, don't we? So let's see. First thing I'm going to do is let x be equal to 1, right? And I'm going to help myself as much as I can. So I'm going to say let x equal 1. Then I have minus 2 plus 4, that's 2, is equal to 0 plus 2b plus 0. Does that look right to you? Everybody? Why did I pick x equal 1? Because I knew this would go to 0, and I knew this would go to 0. And that 2, and then this is 1 squared plus 1. Everybody okay with that? So that's going to help us sum. That tells me that 2 is equal to 2b, and that b is equal to 1. Okay? So now I'm going to have, b is equal to 1. I'm going to have, watch this. What did I do? What did I do? I just took the b out of the problem, didn't I? Given that it's looking messy, right? I knew I was going to have a mess on my hands, so what I did is I took the b out of the problem, and now that reduces the scale to just 2 variables, doesn't it? Everybody agree? So now I'm going to put together what I know. Let's see.
Is that negative 2x plus 4?
Yeah.
Negative 2x plus where?
Yeah, right. The way you just wrote, it says negative 2x plus 1 is that plus 4.
Yes, it is. Thank you. Okay, so now I have minus x squared minus 2x plus 3 is equal to ax to the third minus 2ax squared plus ax plus x squared minus 2x plus 1 plus cx to the third minus cx squared plus, let's see, plus cx minus c. Does that look right to you?
Wouldn't the CX, wouldn't it inside? Cause you got a.
I do C times X, that's that CX. Wait a minute. Yeah, C times 1 times X is that CX. Is that what you're talking about?
Yeah, never mind. I thought you, never mind.
And now I'm doing C times 1 times minus 1, and that's where I get the plus C. For heaven's sakes, watch me. Does it look okay to you? This is deadly if you make a mistake in here, wouldn't you say? Okay? Now, let's see what we have here. I have minus x squared minus 2x plus 3 is equal to a plus c x cubed. Then I have plus a minus 2a plus 1 minus c. Wait a minute, where is my 1? There's my 1, and there's my minus c. X squared. Then I have plus ax, with no x's. A takes care of that one. Minus 2 takes care of that one. Plus c x. And then I have plus 1 minus c. How's that look to you? Everybody having fun? Now, here's where you live by your wits. That is, we've got now 1, 2, 3, 4 equations to solve. I've got this equation, this parentheses, equal to 0. Why is it equal to 0?
There are no x cubed terms.
There's no x cubed over here, right? Then I've got this equal to minus 1. Agreed? Hmm? Everybody okay? Everybody? Then I've got all of this equal to minus 2. And then I got all of this equal to 3. And it is that last one where you get to sing the Hallelujah chorus. The Hallelujah chorus, oh, hallelujah. Anyhow. Why? Why?
It's easy to get that one.
Well,
Instead of equal to 0?
Equal to 3.
See,
I know that 3 is equal to 1 minus c. So minus 2 is equal to minus c, and c equals 2.
So in the original that's right under b equals 1, you're negative 2x plus 4 minus x squared minus 1. You made b equal to 1, and then you brought what b was next to over to the other side. That's where you get that negative sign, the minus, right? Instead of multiplying.
I moved this over there.
It's further back. It's the original.
Yeah, but that two is, that negative's not there. It's minus 2, isn't it?
Yeah.
I moved the one over to the other side.
Let's
Now-
talk about your first one. You're right under b equals 1. It's x plus 4 minus x squared minus 1, or 2x. What you did was you made b equal to 1 the original equation, and you
That's
brought
it.
You brought it over to the other side.
That's it.
Okay.
Your book does not do it that way. But if I know I've got a stretch of numbers that long, and I can get rid of one of them, I'm going to do it. Now, I know that C is equal minus 2, but what'd you tell me about this? What is this equal to?
0. 0.
Well, I had 2 or 3 telling me this a minute ago. What's the power of x cubed over here? 0. So didn't the power on the left side equal to the power on the right side? Isn't that what we did with the 2? I took the 3, didn't I put the constant on the left side equal to the constant on the right side? Is that right? Yes or no? Either you are asleep or you're lost. And if you're asleep, I can't do much for you. But if you're lost, I want to help you.
I just never saw something where it's like this power is equal to this power on this side.
Well, what I did was I just multiplied everything out, and then I grouped them by factors of x. By powers of x, huh? With the last one being x to the 0 power, right? And then what I said is, the coefficient of x cubed over here, isn't this 0x cubed? Doesn't that say x cubed is not there? Yes or no? Okay. So now I took the coefficient of x cubed. I'm going to take that. So what does a plus c have to equal?
0.
A plus c has to equal 0. Huh? If a plus c is equal to 0, that means that a minus 2 equals 0, and that a is equal to 2.
It almost seems too simple to be true.
What?
It almost seems too simple to be true.
The whole key to it, and the book did not do this, the whole key to it was when you find one, get that one out of there. I just took that b and took it out of the equation. That's the whole key to it.
Saves you a lot.
The booklet made it look way harder. Jake?
Okay, how are you getting rid of this negative 2a plus 1 minus c x squared and the a minus 2 plus c to x? Like, how is that?
What I'm telling you is if you put these 3 in, you will get minus 2 right here.
So all you did was take that last one, just set it equal to 3, and then solve for c, and then you plug c back into
Yes.
A.
Where did I get the, I took the last one because it's a constant, right? And I set it equal to the constant. And once I got it, I could have used any one of these. This one, or this one. Why did I use this one? easiest. Exactly. Now let's test it. Jake's gonna make me prove it. I get, right here, A is 2, so I get minus 4 plus 1 is minus 3, and a minus 2 is,
Positive 2, so it'd just be, or,
x squared term is minus 1. Don't I get, if I put 2 in the place of A, that's minus 4. Plus 1 makes it minus 3. So, and then a minus 2 is a plus 2, which makes it negative 1, which is what it,
So what you want to do is whenever you plug it back into each of these, you want it to equal what its counterpart is. on
Yeah.
each side.
yeah,
Okay.
and it will,
Makes it more simple then.
and it will, yeah, that's why I did it this way.
You just gotta make sure you're moving everything in the right place.
You gotta be
front,
careful.
You gotta make sure whenever you move, like the top, you gotta make sure you're moving the negative x squared minus 1 over. And I'm guessing that came from where you got b times x squared plus 1. In the,
Jake, what are you talking about? Say
at
it
the
again.
very beginning up there.
Right here?
Yeah, the negative x squared minus 1. That, I guess that came from where it says plus b times x squared plus 1. I'm guessing you moved it from there.
What I did is, I said, this was b times x squared plus 1, but I knew b was 1. So didn't that have just x squared plus 1?
Yeah. And then you just moved it over.
I just moved it over to the other side. And got it out of my way.
Sounds good to me.
What if you didn't have, what if you wouldn't have done that before?
You still got the right answer.
So it took a little
X squared plus 1 would still be on the other side.
Yeah.
Between A and
You'd
C.
still got the right answer, but you'd have worked harder for it. But you'd have still got the right answer. But the key is taking that b out.
So once you find 1,
Once you find 1, take it out. And unless you see what to do when you have found the second one, take it out also.
Are you staying consistent with x equal 1 the whole time?
Let me get everything on here. That does it. Get out. The x equal 1 is only good for that much.
And then it can equal anything.
Yeah. Only reason I did x equal 1 was that's the same trick we've been doing, isn't it?
Just doesn't seem like it work out if it equals something else somewhere else.
It will. It'd better.
Just kind of one of those things I gotta believe you.
Now it's an equation. It's an equation, so it has to.
But x doesn't have to equal 1 the whole time.
Nope. But the b has to be 1 all the time. It's the b that gets fixed, not the x.
Okay.
See, you were saying, well, x had better stay 1 all the time, or b is not going to be equal to 1. And what I'm telling you, b, once I know what b is, it's going to stay there, and then I can go back and do anything I want to with x. Very good idea. That was good thinking. You've got a question?
Oh, just stretching.
Everybody? That one, if you don't believe how ugly that one could have gotten, look at the way the book did it. When you get home, take a look at that example in the book, and And that's ugly. Any questions? Okay. Let's do another one. This is example 5. Oh, I'm not through. What am I talking
We
about?
didn't finish.
What am I talking about?
Yeah.
A is 2, 1 minus 2. A equal 2, B equal 1, and C equal minus 2. So, wasn't that the whole purpose of what we did?
Yes.
Everybody agree? And do you follow all I did is put those in the place of A, B, and C? I literally erased the A, erased the B, erased the C, and put those in, didn't I? Okay? Now we've got to try to integrate those babies. How many integrals do you see?
3.
Well,
How many integrals do you see?
4.
Who said 4? Very good. Very good. So I is equal to and this is I1, I2,
That's how you see 4.
I3,
You can separate the plus on the top. It's the
Yeah.
one, it's the one on the bottom you have to watch out for.
all right? I draw the line in the dirt. This last test, a couple of you pushed me over the edge, and the gauntlet has been thrown down. And that is, if any of you start integrating right there under one of them, and just scratch around and say that something's equal to something under there, and not all of them, I'm going to mark the whole thing wrong and stop grading right there. And remember, that's the final exam. Trust me, I mean it. You will do it this way. Okay? Okay, now we just stop, don't we? We just stop and we do I-1, I-2, I-3, and I-4, right? So,
What were you talking about, whenever you said you don't want us to just...
here's what I was talking about. Suppose you take this one and you say that this is equal to minus 2 times the integral of 1 over x minus 1 dx, which is equal to minus 2 log x minus 1 plus c. If you do that, I'm going to stop grading, count the whole thing wrong, and move on.
You want the eyes in front at least.
No, I want 4 separate integrals.
You want us to put I is equal to I1?
I want you to do it like I'm about to do it. Okay? You didn't have a problem on that last test. So just do it the way you've been doing it. Everybody follow? So the next thing you're going to do is do you agree? Then we're going to find each of them separately. And then we're going to put them together and call it I, and we're through. Okay? So, here we go. May as well do them in order. I1 is equal to the integral of 2x over x squared plus 1 dx.
Let u equal x squared plus 1.
Do what, Jake?
Let u equal x squared plus 1.
Louder.
Let u equal x squared plus
Yeah.
1.
X squared plus 1. U equal x squared plus 1. Du is equal to 2x dx. So I1 is equal to 1 over u du. Is that right? Everybody? Which is equal to log u. I'm going to leave the c's off because I'm going to put one on at the end. Is that okay with you? It's okay. It'll be okay with me as long as you put that one on the end, which is equal to 1 over x squared plus 1. I'd better put the plus c. I'm not going to copy it though. There's I1.
Shouldn't it be...
Oh, I know. I was talking, Jakes.
The log of x squared plus 1.
The log of x squared plus 1. Okay? Now I2. Am I right?
Yeah. Wow.
Isn't that the inverse tangent? You're going to have to look on your handy dandy 3x5 card. Now, number 3. I3.
Hitchcock.
Hmm?
Why wouldn't that be the natural log of x squared plus 1?
Well, what's the derivative of x squared plus 1?
2x.
Do you see that in the numerator? Remember to have for an a natural log, you take what's inside the log in the denominator, and then you take the derivative of that and put it in the numerator. So here, u is equal to x minus 1, tu is equal to dx, so that's equal to the integral of 1 over u squared du, but that's equal to u to the minus 2, right? So isn't this minus u to the minus 1 plus c, which is equal to minus 1 over x minus 1 plus c. Is that right? Now I4, I did I4 a minute ago. Do you think that's right? Everybody? I4, if you don't see, what is the derivative of x minus 1? 1. So don't you have x minus 1 in the bottom, the derivative of it in the numerator, so it's already set up for you? But if you don't want to do that, wouldn't you just say u is equal to x minus 1? Everybody? Now come on and tell me, doesn't that look a lot better than scratching all over the page? And you can go back to it if you need to. That's all I'm saying, is you're going to do it this way, or I'm not going to grade it.
Sounds reasonable.
Okay? Now all we do, now we're going to go back to what I is, and I'm going to substitute every place, and I'm through. So, I say I is equal to log x squared plus 1 plus inverse tangent x minus 1 over x minus 1 minus 2 log x minus 1 plus c. Any questions?
I don't know.
That's a 2-pager, huh?
I2, say we're dumb and we do x squared plus 1 equals u. And we still do, we put the 1/2 in front of the interval. That would come out to 1/2 times the natural log of x squared plus 1. If we did it wrong like that, but I'm sure our identity what's the identity that comes out to the inverse tan x? I should
Tell me, say that again.
and I2,
I too,
if I were not as intelligent as you think I am, and I did 1 over u, which is u equals x squared plus 1.
Well, watch what happens. Let's just do it. Let's just do it. I2 is equal to the integral of 1 over x squared plus 1 dx. And you're saying, let's try u equal x squared plus 1.
Can't get rid of that 2x.
Huh?
The derivative still has an x in it.
Because you wouldn't have.
Then du is equal to 2x dx.
Okay, that's right. Yeah, I'm forgetting the x and the derivative.
That therein. The problem is not the 2 because you can easily put a 1/2 over here. You can get 1/2 du, but that's equal to x dx. And that puppy right there, you can't create an x. You can create a 2, you can create a 1/2, but you can't create an x.
I just want to do proof real quick, because I know naturally I'm going to go to that, and then I'll get to there, and then I'll be
Yeah.
like, what did I do?
Well, hopefully it'll stop you. That's unless you're so determined that that's the way to do it that you just ignore the x. But hopefully you'll get to that x right there and say, uh-oh.
Try to prove faulty algebra. Okay.
Everybody okay with what we did? That's a 2-pager. That was 5.
That was 4.
6 is too easy.
That was
7's too easy.
Save it.
You just did 4.
Hmm?
You just did 4. You did 5.
That was 4 we just did?
Yeah.
Oh, okay. You want me to do 5?
Sure.
5 is similar to 4, and that'll give you another example of doing this. You want me to do 5? 5 has the possibility of getting a little messy.
Everything has possibility to get messy in here.
And don't call it cow tooth for nothing. I believe you were warned about chapter 8, huh?
Yeah, unfortunately.
A little bitty problem like that. Who would think that that'd be a problem?
Me? Just follow the minutes.
It looks so cool.
It just looks wrong.
Boy, if I let u be equal to x squared plus 1, I'd need an x in the numerator, wouldn't I? That's close to being one we could just do a substitution. But close only counts in horseshoes and hand grenades, right? Okay? So here we go. I'm going to take that.
Got that master lined up yet.
that rule 3 I wrote out? I said if you've got a factor that is irreducible, you have to represent every power of x less than the degree. So I had to have ax plus b in 2 places, huh? Everybody agree?
AX.
Well, I meant something times x plus something.
Wouldn't matter if the last 2 bottoms are switched, or
Wouldn't matter,
wouldn't matter.
any order.
Okay.
You could and people do that, and y'all drive, of course you drive me nuts on the test, but I can't fuss at you about it, because you get to put them in any order you want to.
I probably would put them the other way.
Start with x squared.
It just seems like it'd be more natural to do it that way.
Just start with the x squared, fine.
Go in order.
Then you'd have ax plus b over the square term. Then you'd have cx plus d over x squared plus 1, and then you'd have e over x. And when I'm grading it, my key will have a equals something, and my a will be your e. And that's what I mean about it drives me nuts, but I can't tell you where to start. I don't want to. I want you to do it the way you want to.
Yeah, I mean, you couldn't say it was wrong because it was all come out the same, just different letters.
That's correct, and it's not wrong. It's not wrong as long as you, after you integrate, won't you get the same thing?
You should.
But as you know, I don't grade the answers, so I need to, anyhow. It's okay, you can put them in any order. All right?
So whenever you got x squared plus a number, the denominator, what you're saying is you can't reduce that, so you have to put that
ax plus b.
plus b, that form.
Yeah, yes, that's exactly
But if
what I'm
it's
saying.
squared, then you have to have your
Yes. Yes. Yes.
I just wonder, on like a side note, the other way to do this would it be to just like fact everything out and put the x's in everywhere and then see what you got? It's just
You
it's so,
can't break it up.
it's just so unorganized how you have it like x and then it's x squared plus 1, all that square. It seems like you factor that or
It's already,
But you can't,
it's already in effect.
what you're saying is, why don't you just multiply that out?
yeah, and then put the x and multiply it in there and then see what you
And then what?
I don't know, maybe you have more pluses and you'd have more integration by parts and you'd work it out.
But if you have pluses, you can't do this, remember?
Right.
And near as I can tell, aside from the table of integrals, that's the only way I know to work partial fractions.
I was just trying to see if there's a way to make it look better.
Think partial fractions when you've got something multiplied by something in the denominator.
Yeah, like, for example, you would have x cubed plus 1, then we have bx squared plus c, right?
If you multiplied it out,
Yeah.
if you, are you talking about
No,
multiplying this out
No, I'm talking about the, in the example in the.
up here?
Yeah, our problem, instead of x squared, you would have x.
Yeah, watch what happens. Watch what happens. I've got 1 is equal to a times x squared plus 1 squared plus bx plus c times x times x squared plus 1 plus dx plus e times x.
What he was saying is like in the original problem, if you had like the integral of 1 over x times x cubed plus 1 squared, whenever you get over here to like the bx plus c, What he's asking is, would it be like bx squared plus c?
If you had a cube there,
Yeah, and
you would have this square, then you would have another term right here. Y'all don't write this. This is based on Jake's question. And Jake's saying if that was a 3, right?
No, the other one, the x squared. If it was x cubed.
Okay. If it is x cubed, then you would have bx squared
Yeah.
plus cx plus d.
Oh, that's whenever it gets fun, huh?
Yeah, this is bad enough.
Yeah.
But then over here you would have ex squared plus fx plus g. Okay?
Would A not be A times 2 and then the x squared plus 1 squared? Alright, no, I guess that would make sense. How come you don't add the first x squared plus 1?
Because it's the same.
You're essentially cross multiplying.
That's, I wouldn't call it that.
Now look at the denominator on the other side.
Look, let's do it. I've got a over x times x squared plus 1 squared. Isn't that what I'm doing?
Okay.
And that's where I get it.
Okay. You're just looking on the other side, not really.
Yeah,
Yeah,
The original,
denominator.
You
Multiply everything by the original denominator.
Then you plus 1.
Makes a lot more sense.
And I do that all the way down. And there's nothing at all wrong if you go off to the side on the page and write that out. That is not high school chicken scratch. It's high school chicken scratch when you leave off equals and when you try to tell me this is equal to that integral and stuff like that. Okay? But off to the side, simplifying it, I'm a big boy. I've had to do it off to the side myself. I can figure it out. Okay? Questions? Now,
Let x equal 0.
yeah, Jake, that's exactly what I was thinking.
Can't let it equal 1.
Let x equal 0. We'll get some help, won't we? I got 1 is equal to a
1.
Yeah. plus 0 plus 0. Do you agree? Everybody? Okay, so now if A is 1, then that means that this is x to the 4th plus 2x squared plus 1. Is it not? I just squared it.
Yeah, you fold.
Okay, so now I have minus x to the 4th minus 2x squared plus 1. Nope, minus 2x squared
No, cancel out.
minus 1 plus 1 is equal to, now this is bx to the 4th plus bx squared plus cx to the 3rd plus CX plus DX squared plus EX.
So you multiply the rest all out.
I just multiplied everything out.
Why would it not? Why wouldn't it? Wouldn't that be bx cubed?
Where what?
Wouldn't that be bx cubed?
Right here?
No, bx.
No,
B-
he's already got an x, and then you times it by that x, and then you times it by the x squared.
Okay, let's see. I multiplied BX times X. That's BX squared times X squared is BX to the fourth. Then I multiplied BX times X. That's BX squared times 1.
Oh. Okay.
Okay? And then I did the same thing with C going across. Beth, you see anything wrong with it? Everybody okay? All right, let's put it together and see what we can do, shall we? I now have minus x to the fourth plus 0x to the third. I'm not going to do that. This isn't high school algebra. Minus 2x to the third is equal to
Squared.
Squared.
squared. Thank you. Is equal to bx to the fourth. Look at that. I say yes. Look at that. We got b just that fast, didn't we? Plus cx to the third plus b plus d x squared. Now we know what d is, don't we? Plus c plus e x. See what you think.
C plus e is 0.
Is my algebra right?
It looks right.
Then I take note that b is equal to -1. Doesn't it have to be?
D is negative.
C is
negative
equal
1
to 0, isn't it?
Now, what?
D is negative 1 as well.
And then d, look at x squared. I know that,
It's negative.
consider,
Negative 1. B is negative 1. So you got to add negative 1 plus
I
1.
know that b, I know that b plus d is equal to -2. But that's -1 plus d is equal to -2, or d is equal to -1 also. Now we're cooking. Okay? I also know that C is equal to 0. No questions asked. Why?
Because there's no x.
There's no x cubed term, right? Agreed? Okay? Then I know that C plus E is equal to 0, which means that 0 plus E is equal to 0, so E is equal to 0. What do you think? What?
I think it's looking good.
And then the last thing I need is D, right? No, I got D.
You got all of
You got everything.
I got everything, don't I? Wait till you see what the book did to that one.
No, I already do it.
Questions? So, here we go. 1 minus 1, 0 minus 1, 0. 1 minus 1, 0 minus 1, 0. Okay with me? I couldn't have done that without trying. That's old.